Welcome, dear students, to another very important topic of the general organic chemistry, and that is the mesomerism or mesomeric effect, which is represented by capital M. And this concept was introduced by Ingold in 1938. My dear students, the mesomerism is sometimes also called as the resonance, and the mesomeric effect is sometimes called as the resonance effect. And this concept of resonance was introduced by Pauling, and it is shown with the capital R. But there is a difference between these two concepts. What is the difference? We are going to discuss in this lecture. Look at these two structures. You are quite familiar with these two, structure 1 and structure 2. They are basically the two structures of the benzene. They are also called as the Kekulé structures. Now, what is the similarity between these two? These two structures have same structure mean. Overall, the shape is same. Both are hexagonal and all the bond angles in both are same. They are 120 degree. So these two forms, they have same structure mean. Overall shape is same. The bond angles are also same. Similarly, both these forms, they have same position of all atoms. It is hexagonal and every corner of the hexagon is occupied by one carbon atom. In the same way, it is also hexagonal and every corner is occupied by one carbon atom. So the position of 6 carbon atoms in both these structures, that is same. Both these, they have same energy. They also have same number of total bonds. The total number of bonds in both these structures, they are same. So the total bonding electrons, that will also be same. If they have all these parameters same, then what is the difference between these two? You can see that the difference is in the arrangement of the bonds or the distribution of the bonding electrons. Here you can see a single bond, but in the structure 2, here is the double bond. So this is double, but in structure 2, this one is the single bond. It means that the two forms, they have same structure, same position of all atoms, same energy, same number of bonds and bonding electrons, but the distribution of electrons or the bonding arrangement is different in these two. Such kind of forms or such kind of structures having all these properties same but different distribution of the electrons or bonding arrangement, they are called as the resonance structures or resonating structures or canonical forms. So these are two resonance structures or canonical forms of the benzene, which are attached to one another through this double-headed arrow, which is a sign of the resonance. My dear students, these two structures are resonating structures and this phenomena is resonance. Can we call, this is a question from my side, can we call these two structures as the mesomers of each other? Or can we say that this phenomena is also the mesomerism? It is resonance, but is it mesomerism as well? We will say no. It means there is difference between the resonance and mesomerism, and what that difference is, let us discuss that. But before discussing it, keep in mind that these two structures are also the conjugated systems. You are well aware that conjugated system means presence of the alternate pi bonds, mean double bond, single bond, double bond, single bond, double bond. If this arrangement is seen in a structure, we will say that it is an example of the conjugated system. Now, what is meant by the mesomerism and mesomeric effect? If it is different from resonance, let us discuss it. Dear students, this one is a structure in front of you and you are well familiar with it. It is phenol. And this one is again a conjugated system and benzene is attached with the aldehyde group and this one is benzaldehyde. Now, my dear students, look at this first case. In that case, the OH group is attached to the benzene ring. Now the oxygen of this OH group, it is electron rich. It has lone pair of electrons. It has non-bonding electrons. So it is electron rich. It will like to share its electron with the benzene. Now what happens? By using these two electrons, it will like to form a double bond here. But as the carbon can form only 4 bonds, So this carbon will have to shift one pi bond or the two electrons of the pi bond to the next carbon. Now what will happen? The structure will become double bond O. As it has shared its lone pair, it will get positive charge. The pi bond is, the two electrons of the pi bond are given to this carbon, it will become negative, and the remaining bonds will remain same. Now, the charge is a burden. Keep this sentence in your mind that charge is a burden and every atom wants to throw that burden. So, this carbon will like to throw its negative charge and it will use the two electrons to form a pi bond here. And as this carbon can form only four bonds, so it will have to shift its electrons to the next carbon. Now, what will happen? The structure will be changed to something like this: double bond O, H. Here will be the double bond O due to shifting of this negative charge. This carbon will become negative and this bond will remain unchanged. Now again, the carbon will like to throw its burden to the next carbon. It can form only four bonds, so it will have to move its pi bond to the next carbon. What will happen? Double bond. Due to shifting of negative charge, here the pi bond will be formed. This carbon will get negative and this one will remain same. Now again, this carbon will like to throw its negative charge to the next carbon, and again the lone pair of the oxygens, they will be given back to it, and now the structure will be OH like this. Now my dear students, look at this structure 1 and structure 5. Are these two structures same? You will say no. There is bonding arrangement, different bonding arrangement in both these structures. You can see that in the structure 1, this one is double bond, but in structure 5, here is the single bond. And now all these structures, they will also be connected through a double-headed arrow. My dear students, now all these structures, they are resonance structures as well as they are mesomers of each other. So both they are resonating structures as well as the mesomers. These structure from structure 1 to 5. They are mesomers of each other and they are also the resonating structures. Now, my dear students, these are the mesomers as well as the resonance structures, but they are only resonance structures. Why? Now, listen this very carefully. If there is a molecule which is not attached to any group, any functional group, and it shows more than one forms, then that phenomena will be called as the resonance, and those two forms will be called as the resonance forms. But if a conjugated system or a molecule is attached to some functional group, and due to electron donating or electron withdrawing property of that functional group, different structures they arise, then that is called as the mesomerism. For mesomerism, it is necessary that there must be some functional group attached to the conjugated system. But if there is no functional group attached to the conjugated system, that will be called as the resonance. If the functional group is attached to the conjugated system, then different forms arise that will be called as the mesomerism as well as the resonance. It means resonance is a much broader concept and mesomerism is a subset of the resonance. So resonance is a much broader concept and mesomerism is a subtype of the resonance, you can say. You can also say that if a conjugated system is organic in nature and it is attached with some functional group and it shows resonance, then that resonance is basically called as the mesomerism. And those forms are called as the mesomers. Now, what kind of group it is? This is OH group and it is electron donating group. It has donated electrons to the conjugated system. So, this OH group is basically, you can say, this is electron donating group. All the groups which are electron donating, when they donate electron to the conjugated system, this is called as the positive mesomerism and these are called as the positive M groups. There are so many examples of the positive M groups, but keep in mind that all positive M groups or all electron donating groups, they have either lone pair of electrons or they carry negative charge. Because when a atom carries lone pair of the electrons or negative charge, it is said to be electron rich. And an atom which is electron rich can donate atoms to the conjugated system. And when these groups they donate electrons to the conjugated system, what happens? We will say that electron density of conjugated system increases. And because electron density increases, the attack of the electrophiles becomes easier and the attack of the nucleophiles becomes difficult, as the electrophiles are those species that are loving, that are the electron loving, basically that are the negative loving. So the electron density of the conjugated system will increase and its reactivity towards electrophiles that will also increase. Now, my dear students, if we are specifically talking about the benzene as the conjugated system, and when the electron donating groups will donate electrons to the benzene ring, only ortho and para positions will become electron rich or negative. You can say the negative charge is either on the ortho positions or on the para positions, the meta position that never gets the negative charge. Now, my dear students, it means when the electron donating groups will donate electrons to the conjugated system, then the positions that will become negative, they will be more vulnerable to the attack of the electrophiles. So the mesomeric effect also decides the points that will become the electron rich and that will be the sites for the attack of an electrophile. There are so many electron donating groups like O negative is an example of electron donating group. NH2 group, NH R group, amino group. This one is basically the secondary amine group. Similarly, tertiary amine group, that is also an example. OH group, OR group, they are examples. And then you can say all the halogens, fluoro, chloro, bromo, iodo, even the phenyl group, that is also C6H5, that is also electron donating group. And my dear students, the order of their positive M strength will be negative oxygen have maximum positive M effect. It is the strongest positive M group. And then the strength decreases like this. So they are all the electron donating groups are positive M groups basically. Now let us see the second case in which with a conjugated system the aldehyde group is attached. Now my dear students, the carbon which is attached directly to this conjugated system, that is very poor. That is electron poor basically. Why it is electron poor? Because it is attached to a highly electronegative atom, oxygen. Oxygen will take bonding electrons from the carbon and the carbon will become the electron poor. So this carbon, instead of taking electron, instead of giving electrons to the conjugated system, it will withdraw electrons from the benzene. So this pi bond that will be shifted here As the carbon can form only 4 bonds, so it will donate the 2 bonding electrons to this oxygen atom. What will happen? Now the structure will become something like this. It will be double bond C, single bond O negative, H, and because the bonding electron of this carbon is also moved here, so it will get positive charge. Now in order to overcome its positive charge, it will take pi bond from this carbon, and this pi bond will be shifted to this position, and then the structure will become and now this carbon will get positive charge as its valency is not satisfied. Again, to overcome its positive charge, it will take these pi electrons, and now the structure will become and this carbon will get positive charge. Again, it will take the pi electrons, and then the negative charge of oxygen will be shifted here, and the resulting structure will be, it will look like the first structure, but it will be different from it. Now these structures from 1 to 5, they all have the properties of the resonating structures, mean they have same shape, same position of all atoms, they have same energy, they have same total number of bonds and bonding electrons, but again the bonding arrangement and the charge distribution is different. So they are basically resonating structures, and as a functional group is attached to conjugated system, so they will also be called as the mesomeric structures. So in that case also, these 5 structures will be called as the resonating structures as well as the mesomeric forms, as the functional group is attached to the conjugated system. Now, my dear students, in the first case, there was an electron donating group attached to the conjugated system, but in the second case, this aldehyde group has withdrawn electrons from the conjugated system, due to which this will be called as the electron withdrawing group, and all withdrawing groups will be showing negative mesomerism. They will be called as minus M groups basically. And instead of increasing electron density of the conjugated system, they are giving positive charge to the conjugated system, which means that the electronic density of the conjugated system will be decreased. When the electronic density of the conjugated system will be decreased, then the conjugated system will not be favorable for the electrophilic attack. Electrophiles will not attack on the conjugated system, rather the attack of the nucleophiles that will become easier. And even if the conjugated system is benzene, again the positive charge will be occupied by only ortho and para positions. Meta position never gets negative or positive charge in both cases, in the electron donating case as well as in the electron withdrawing case. Now, my dear students, there is a trick to memorize that what kind of groups they are showing negative and what kind of groups are basically positive M groups. For the positive M groups, we have already discussed that all those groups in which the central atom has lone pair of electrons or it has negative charge, they are basically the positive M groups. Now, the negative M groups are all those groups in which multiple bonds are present between heteroatoms. All those groups in which multiple bonds are present between the heteroatoms, they are basically the negative M groups. And the famous examples of the negative M groups are NO2, CN, in which nitrogen and oxygen they are attached to double bonds, carbon and nitrogen they are attached through the triple bonds. Sulfonic acid group SO3H, in this group again sulfur and oxygen they have multiple bonds, and similarly the aldehyde group, the keto group, they are all having the multiple bonds. In the same way, I am writing down here carboxyl group, it also has multiple bonds, and amide group. So these are all basically the examples of the negative M groups, in which you will see this feature common in all of these. They will be having multiple bonds. NO2 group is the strongest negative M group, and as we move towards this side, the negative M strength will keep on decreasing. These two are written here. So these are basically the negative M groups. And what is their order of the strength? I have also mentioned their order of the strength of the some common groups that show the positive mesomeric and negative mesomeric effect. So, dear students, let us conclude the lecture. The mesomerism is a subset of the resonance, especially when we are discussing some conjugated organic system attached to a functional group. And resonance is a broader concept which is applicable to inorganic as well as the organic molecules. But in case of organic molecules, there will be a conjugated system, but that conjugated system will not be attached to any functional group or any extra substituent, just like the benzene. So this was all about the mesomeric effect and mesomerism. Next time we will come up with some new lecture. Till then, take care.